All right. Good afternoon, everybody, or good morning from wherever you may be joining us. My name is Mark Ogg. I am the current past president of CSINext. Happy to welcome you to the April 2025 chapter meeting. Our program this month, presented by yours truly, is Prevention Through Design. Minimizing hazards for those who construct, operate, and use facilities. You will notice that the background here is from one of the previous construct slide decks. I was fortunate enough to give the early version of this presentation in 2020 at the virtual Construct conference in the National Conference for CSI at the time. I've given it a couple times since, updated it the last couple years, and just recently presented it to the Ohio Valley chapter back in November at their EduCon event. And it's been very well received. I think you will find this to be very informative and helpful in your daily design and construct of facilities. So got my screen shared here. I think we're ready to go. I'm going to turn the camera off. During the presentation, if you've got any questions, just type them into the Q&A option, and I will get to them as soon as I can. This is a eligible session for learning units with AIA. So at the completion of the seminar, you will receive a Zoom survey link for the meeting. Typically takes about 24 hours. So you should probably get that tomorrow or sometime over the weekend. If you need AIA certificate confirmation information, please fill that out. And then we will download it and get you the information that you need. So without further ado, I will go ahead and get us kicked off here. Again, the presentation today is on prevention through design, minimizing hazards for those who construct, use, and operate facilities. Trying to get the screen to move here. There we go. So a little bit about your presenter today. Who am I? Well, again, my name is Mark Ogg. I am based in Cincinnati, Ohio. I'm a senior project manager for JLL, also known as Jones Lang LaSalle, and I work on the Procter & Gamble account here in the Cincinnati area. Got about 30 years in construction management, project management, and consulting. Commercial, industrial, life sciences, R&D, and manufacturing markets. Educationally, I have a bachelor's and a master's in construction management. Attended the University of Cincinnati and Western Carolina University. Professionally, I'm affiliated with CSI. Currently a member, past president of the CSINext chapter board of directors, and currently the CSI Great Lakes region vice president, and I've been a member of CSI since about 2013. Professional credential wise, I have my CCCA, my CDT. I'm a PMP as well, and I have also been certified through the OSHA construction and general industry, both 10-hour and 30-hour certification courses. So what are we actually talking about today? Well, we're going to talk about how safety goes beyond just the construction of a facility. It encompasses those who visit, work in, and maintain those facilities. And it is a part of the entire facility life cycle, from the very conception all the way through turnover and ongoing operations. So by designing for safety, we can eliminate the potential for hazards, reduce costs from redesign and retrofitting later on, and allow for sustainable, safe operation and maintenance of the facility as well. So in learning objectives today, one, we are going to define what prevention through design is. That is an actual acronym known as PTD, what it is and why it is important. We're going to recognize how PTD is applied during the project delivery process, how it is linked to sustainability and the challenges that industry professionals face. And we're also going to apply tools and work processes that can help assist in designing for safety. And we're going to look at a couple current industry applications and their impacts based on actual case studies through the application of prevention through design. So, safety in the built environment is defined as the condition of being safe from causing hurt, experiencing injury, or loss. And in the built environment, there are three main areas of safety. The job site, which is the responsibility of the contractors and the construction managers. The design aspect, where our architects, engineers, specifiers, suppliers, consultants will abide by the codes and the regulations, and then also any client-specific needs for that related facility. And then there's the operations aspect of it. Once the facility is in operation and the assets are turned over, the ongoing maintenance, the ongoing upkeep, and any activities that would result as ongoing operations of that facility as well. And the one thing that safety always is, no matter what area you are in of the three, it is always everyone's job. And whether you're walking around a job site doing an observation report, whether you are on a facility at a client meeting, whether you are talking about the design of a facility and different aspects of how things need to be designed into the facility, I always tell people, if you see something, say something. Nobody is uh, worth getting hurt, yourself or anybody else. So again, if you see something unsafe going on or you have a question on something, please speak up, say something. You could protect yourself, you could save yourself from injury and those around you. So safety is always everyone's job. So before we get into uh, talking about what prevention through design is, little history of workplace safety and kind of how we got here. Prior to 1970, I lost my screen there, folks. Sorry about that. Let me get back to a little technical issue here with PowerPoint at the moment. Apologies for that. I think I clicked the wrong button. There it is. Let me reset the screen share here. There we go. All right. Sorry about that. So a little bit of the workplace history. Click on the topic here. Yes, prior to 1970, the industry was, accidents were common, whether it was construction, whether it was industrial, the office. Accidents were a common occurrence in the workplace in general prior to 1970. Workplace and worker safety was generally not a central focus. Industrial and construction arenas were very dangerous. Accidents were considered cheap. Not really a concern if folks got hurt. Somebody got hurt, you just bring somebody else in. And the accountability and liability, because there really wasn't a focus on safety, was very difficult to establish. Post 1970, we had the Occupational Safety and Health Act, also known as the OSHA Act, and OSHA was formed. And OSHA's was set up and put into place to ensure safe and healthful working conditions by developing and enforcing standards, provide training and outreach, education and assistance, and then also regulating the construction, agricultural, and maritime and general industries. So through the integration of design and safety, through working with OSHA, through working with the increased regulations and such, that has led us to probably two of the most asked questions regarding design and safety integration. And the first question is, why is it important? And the second question is, how is it accomplished? Well, why is integrating design and safety important? Well, early identification of hazards, preventions of future liabilities, and it also reduces costly rework during construction and operation. Catching an area that maybe needs a handrail or maybe a different application of flooring due to slips or trips. Catching that early on in the design phase instead of catching it at the end is always that is a cost prohibitive move right there. So the early identification of issues or possible issues, you're not going to catch everything, but it's identifying as much as you possibly can early on will greatly reduce the amount of rework that is sometimes required by that. So let me get back to my slide here. Sorry about that. There we go. Okay. Question 2, how is it accomplished? Well, maintaining a safety culture within an organization, training and educating workers of all levels across all disciplines, and the implementation of the concept of what is called prevention through design. So what is a safety culture? Well, safety culture is the value and belief in a worker and public safety by each member of an organization. So everybody in an organization, no matter what organization that is believing in a culture of safety that starts at the top and weaves its way through all organizational levels. That is probably one of the key things. I have found that in leadership in general, especially when it comes to creating a safety culture and believing in that basis, it has to start at the top, and it's a top-down thing. If workers and employees do not see leadership believing in something, they're not going to believe in it themselves. The built environment, it's a melting pot of safety cultures. We have owners who have, they have the responsibility to keep their employees, their workers safe. General contractor, construction manager, they have the daily responsibility to keep the job site safe, keep the project safe, make sure that everybody is working as safely as they possibly can. And then we have the architect, the engineer, and the specifiers who, are required to make sure that things are designed to the required codes, industry regulations, whatever the practice may be, to make sure there that everything is compliant and will be done in a safe manner and comply with what it needs to. By combining these cultures throughout the facility life cycle, it produces a safe and functional facility for all stakeholders. Education and training. Organization-sponsored programs. I know here at JLL, safety is generally at the heart of everything we do, whether it is our own people, whether we are managing projects, whether we are managing sites for clients. There is a very, very heavy focus on making sure that things are being done in as safe as manner as possible. And we are continually trained throughout the year with multiple trainings. Sometimes we have the lessons learned from things that happen, but overall, ongoing training has really helped ingrain that culture of safety within an organization, especially here, and has transferred not only to the employees throughout the company, but then again the clients that we serve. There are the OSHA 10-hour and 30-hour programs, which I personally have found very beneficial to me as a construction manager. Not just from a day-to-day aspect on project sites, but as doing a lot of design build, a lot of integrated project delivery type projects of late, understanding what facilities have to comply with from an OSHA standpoint during operation has been extremely beneficial in making sure that, as I mentioned early on in the program, catching things early. Vendor and supplier programs. A lot of vendors, a lot of suppliers will do, the lunch and learns or the seminars, providing information about the safety of their products, of their programs. So there's a lot of different aspects out there to become somewhat proficient in safety, or at least become knowledgeable about some of the applications. So let's talk about what we're here to learn about today's prevention through design, also known as PTD. So Ben Franklin said an ounce of prevention is worth a pound of cure, and that's kind of the basis for prevention through design. It was an initiative that was introduced in 2007 by the National Institute of Occupational Health, also known as NIOSH. And it seeks to design out or minimize hazards and risks. This is accomplished by application of hazard elimination practices, and then minimizing methods through the design processes, equipment, and with risk mitigation through working with an organization. So what is PTD and what is it not? And this is, I think this is pretty important. Prevention through design, what it is, it includes worker safety considerations during constructability. It makes design decisions based in part on risk to construction and operational workers. It considers and places high value on operational workers during the design of a project. And when I mean operational workers, I'm referencing the users of the facility. It allows for high levels of collaboration and communication amongst all the stakeholders in a project, and it generally involves the owner, the designers, and the contractors. What PTD does not do, or what it is not, it does not have designers, and I think this is super important, does not have designers take an active role in construction safety during the execution. Very clear delineation there. Day-to-day activities on a construction project are the responsibility of the contractor and the contractors on the site. It is not the designer's responsibility to make sure that the site is designed for safety during construction. That falls on the contractor 100%. And it also does not entail specifying the means and methods of construction. So I wanted to get that differentiation out there because I think it's important to understand what prevention through design does is focus on minimizing operational risks early on in the process, not so much during the construction aspect of a project. So there's several key components and building blocks of prevention through design. First one is understanding the hierarchy of controls on safety management, and listing the actions for reducing those risks. It's an order-based system on the reliability and effectiveness of eliminating risks. So the NIOSH hierarchy of controls is eliminate, substitute, engineering controls, administrative controls, and PPE. And those are in order of importance. So the first most important way to address a risk or a possible situation where something may be dangerous is just to eliminate the hazard. If somebody has a possibility of sticking their hand into something operationally that they would get injured, eliminate the ability for them to be able to do that. Substitute the process. Eliminate and substitute kind of work hand in hand together. Engineering controls. Placing equipment, placing hazards, placing walkways clear out of the way of anybody possibly being near a process that they shouldn't be near. Administrative controls, those are typically warning signs, directional signs, and then the last line of self-defense against an injury. And it's a very important one, but it really is the last, I don't want to say last straw, but if we can't do any of the others, then PPE, or also known as personal protective equipment. You don't always want to have to rely on that. You want to try to use one of the other more stringent methods to get the risk out of the way, but at the bottom there is the use of PPE. As you can see, the triangle here: elimination, substitution, engineering controls, administrative controls, and then down here at PPE is at the bottom of the triangle. So management commitment is another key component. The support of the design team. Management commitment in supporting the design team. It encourages, improves worker safety and health, along with other elements such as cost, schedule, and overall quality. And the management must embrace that culture of safety. If I mentioned before, if they don't believe it, people aren't going to buy it. They're not going to believe it. It's kind of like the don't do as I say, not as I do thing. Lead by example. And when management is supportive of the design and the construction team on a culture of safety, goes a long way. Owner involvement has a very high position of influence when the owner is involved in the overall design aspect of a project in general. Depending on what kind of organization it is, they can dictate how safety and health are addressed at the facility level, and they can also help in determining which hazards are eliminated or dealt with during design. A lot of larger organizations, especially a lot of manufacturing plants, have a very robust health, safety, and environmental staff. Those are key components from the owner's side to have involved in projects early on, especially if you are doing a design build or if you are doing integrated design or integrated project delivery. I'm sorry, and even in a design bid build environment, having that owner involvement early on is really beneficial. Team collaboration is another component. Having input from the constructors, the HSE operational personnel, early key input, as we just talked about. This collaborative effort here, especially in the methodologies that we are seeing of late, is really important to getting things addressed early on. So, project delivery with prevention through design touches each phase of the project or the facility, from the concept design through operation and ongoing maintenance and operation of the facility. So in conceptual design, we all know that, it's not very far along in this stage. It might even be, as we like to say, on the back of a napkin. Prevention through design activities for this phase. This is where safety and health goals for the project are established. Early identifications of possible risks and hazards associated with the facility, the project, whatever you may be looking at. Also, this is the time where you establish your sustainability goals. Environmental aspects, any discharges, any off gases, anything like that, you want to get that captured with the team at the conceptual design phase with the PDT criteria. stakeholders involved at this point. Typically your owner, project representative, your owner's operations representatives, any HSC individuals, and of course your architect, engineer, and your construction manager and contracting team. Again, this tends to focus on a very collaborative type delivery. So my experience has been I've used this in a lot of design build and a lot of IPD deliveries. Not so much in a DBB world, but it's very applicable. You just don't see it in that realm too terribly much. Key output for the concept design. So when you have gone through the PDD criteria, when you get to the completion of conceptual design, you want to have a specific PTD policy. So this is going to, provide the direction to the parties implementing the project. What metrics are going to be evaluated? What are we going to achieve? How are we going to do that? And then the overall policy statement that formalizes the commitment to this process by all parties. So kind of like a partnering agreement that, hey, this is what we're all going to work for. Generally done in the original kickoff meeting or one of the first design meetings, gets everybody on board. Everybody knows where they're going and what direction they will go to get there. An example here of a project-specific policy. I can send a PDF of this out if anybody's interested. I won't go through the whole thing, but it's just a very general statement, kind of like early on with a project charter, just establishes the overall goals and what is going to try to be achieved. Moving into preliminary design, now that we've got a little bit of information going on the facility that we're looking at. So this is where the overall facility size, number of stories, orientation of spaces, basic materials of construction. This is the stage where we start to look at all those and start possibly making some choices or have a good idea of what we think we want the facility to be. In this stage for activities within the PTD framework, review of layouts, general shapes, sizes, equipment, materials, storage, developing guide words to help focus the reviews really helps on different aspects of it. If you focus things on studying on orientation, what we like to call human machine interface. What is a person going to be doing with this operation in a facility? Are they going to be standing a lot? Are they going to be sitting a lot? Do you need to look at ergonomics? Do we need to make sure that there's protective barriers between whatever may be going on? Location of different things. Is this group of folks in the office, are they going to be near the utility room? Is there going to be a lot of noise? Just things like that. That's what you start identifying in this phase. And similar to the last phase, the owner of the project may be involved to a degree. Your operations staff typically is heavily involved here because you are talking about the layout of the facility and how things are going to be staged and put together. Any HSE representatives from the client or their risk providers, and again, your AE team and your construction team as well. Key output is the risk assessment pro forma, and we'll take a look at what one of these is. This is an example from the PTD manual, which I will give you information on later on where you can find that. And then this is basically just it's arbitrary. It's team reviewed. Values are assigned. What this basically is this assigns a probability that an injury may occur as a result of as result of a hazard, what the severity of that injury may be, and then what is the exposure, what's the probability of workers being exposed to that. All three of those values are multiplied together on a scale of 1 to 5, 1 being low, 3 being medium, 5 being high. So you can have a total of 125 quote risk value. I think the closer, obviously, the closer your value is to that 125, the more severe the risk needs to be looked at. So let's take an example here, and this is one from an actual project that I had at one point. There were in a utility plant, there were several chilled water control valves for some air handling units that would require occasional preventive maintenance, maybe access to them to make sure they're operating correctly. But they're very high up. They were above the air handler, probably at least 12 feet off the floor. This was caught in design. And one of the hazards identified was, okay, well, falling while accessing the top of the units to get to the valves. So what we did was everybody took a opinion on what they felt everything was. The probability that an injury would occur because of this action was about a 4 out of a 5. The severity, obviously, if somebody falls, severity, especially from higher than 12 feet, could be very, very bad. So that was rated at a 5. And the exposure, the probability to somebody being exposed to the potential of a fall with this operation was fairly high too, because there was no other means to access the area up in the ceiling above the air handler. So it came out to be about a 100 on the scale of 125. The HS&E team decided that, okay, we are going to eliminate that possibility from somebody having to get up there and possibly having this impact. So what was redesigned was the location of the valves, the piping was reconfigured, and the chilled water control system was basically designed to be at a working height right off the floor level. So nobody needed to get up on a ladder or in a lift or climb up in the ceiling around the steel to get to anything. This was all going to be at working height right in front of the face of the individual. So this is something that can be done for any type of risk, and this is something that you continually evaluate during your design. You can really take it in either direction. You can really get into the weeds with things, or you can evaluate the overall high level risk. It all depends on what the objective of the overall team is. So now that we are through concept or through preliminary design, now we're starting to get into the nuts and bolts of things, and putting the detailed design documents together. So this is where we're starting to develop full drawings and specs. We're going to clearly detail what we can of the project's components. And again, we are going to be able to identify hazards as we do final design. Hey, this is going to be an issue and might need to address this. And now's the time that we start looking at those a little bit deeper. This is done through the PTD criteria with the formalized design progress reviews, whether those are 30 at 30%, 60%, 90%. Everybody has their different stages of reviews, but a formalized design progress review can really help focus on this. Again, when you find hazards, detail them, review them in detail, mitigate them based on the hierarchy of controls, and again, go back and reuse that performa that we just looked at. Your stakeholders involved here, owner, operations to a point, definitely during progress reviews, any owner, HSE, or risk representatives may want to also take a look at things. The AE team and the CE team. And then our key output here is there's going to be a log of identified hazards, planned mitigation, and their expected completion timing of those changes. So say we find something, oh, you know what, we're going to need an extra set of handrails here. We're going to have to put a different type of floor coating here because of possible moisture, slips, trips, whatever it may be. Log those, identify them, develop a time frame for when that is going to be addressed and completed in the design package. That way, when you get to the end of your design, you have done as much as you possibly can to mitigate any hazards or conditions that you may find unsafe. There is also a key output here of something called the slide rule, and this is something that can be used during that design process here, and we'll talk about this real quick. This is an actual tool that you can go online and use. It is constructionsliderule.org, and it is a public open forum, takes suggestions and inputs from all across the industry. And what this does is it typically goes through and you put in the details of your project as much as you possibly know, different aspects. So you've got the foundations, you've got the structural, you've got exterior, and you go through and you set the severity of the things that you have and elements that you have. Do you have deep foundations? Do you have, high voltage electric? This will come back and spit out an assessment result of just considerations that you need to take into account while you're designing your facility, to give you a better idea of, oh, okay, well, if you've got a lot of risk electrically, if you're dealing with very high voltages or complex electrical systems, ensuring that everything is compliant with NFPA and clearances and ARC ratings and all that highly technical stuff, that if things happen and things go bad, somebody could get seriously hurt. This is a great little tool for doing that. So again, you can look into it more at constructionsliderule.org. And again, if you want a PDF of this presentation, you could probably see these examples a little bit clearer. Okay, so after we've designed, we're about ready to buy, right? We're ready to procure. We're going to start doing contracts. We're going to start buying materials and equipment and get everything ready to start building. So this is where we do the bidding, we do the permitting, and then we start issuing contracts. So for the procurement phase, this is where we do a lot of some things called factory acceptance testing, prefabrication or modularization of components. Will it be easier to prefabricate these sections off-site and then bring them in and install them, or rather than having to stick build everything in the field, which exposes workers during the construction of it to safety issues. Factory acceptance testing of equipment, this is a big one I've seen a lot of success with. If you're buying a lot of complex equipment, when it comes to medical equipment or mechanical equipment, whatever it may be, there may be especially in manufacturing, you'll see this with production equipment. Clients will go and they will actually witness the acceptance test in the factory of the machine that they are buying to make sure that it is operating correctly when it leaves the factory, and it has been built to the requirements, the safety and operational requirements of the client. So catching that at the factory is a huge benefit before it could possibly be delivered and installed, and then problems arise. So stakeholders, again, owner, operations, and HSE representatives, maybe not so much at this point, but there's some of them may want to participate in some of the verification in the testing. And then again, depending on your contractual relationship, possibly a member of the construction team, subcontractor who's purchasing or installing the equipment may be involved in some of those verification tests as well. The key output here is obviously with the getting ready to go to construction, we're probably going to have a good idea of what the construction safety program requirements for the project build will be, specific to not just in general construction safety, but specific to the project at hand. The end user safety compliance report, you will get that from the factory acceptance test, stating that everything is all the safety switches are on, and any specific client required processes or devices have been addressed. And then you have your procurement checklist. You know exactly what you've bought and what you've checked out. So now comes the fun part. This is when we get to start to build. And even though we're designed and we're bought and we're contracted and we're now putting buckets in the ground and starting to build a facility, the PTD criteria, the process is still involved. Mainly through QA, QC inspections and observations. So somewhat limited activities, again, because we're designed. Most of the work at this point will probably surround changes or revisions from, again, you're not going to catch everything, but now is when you're going to start seeing things as they're actually being built and say, ooh, that may not work. Sit down, analyze it, revise it. And this is where you can really leverage your stakeholder collaboration because when you do go and you do have to do a revision, we all know that not a lot of time on any general building project. So time is always of the essence. Getting those people involved, getting that spirit of collaboration motivates people to want to get things done. So typically in your execution again, your owner, your client, your HSE risk reviewers, and your AE team and your CE team, your CM team are involved in this. And the key outputs during execution, we're going to get feedback during construction. We're going to know what's working, what's not working, what has to be changed. We're going to get lessons learned from that to avoid it the next time. And then you're going to be able to start tracking your effectiveness with the prevention through design criteria, the framework of it, because you've established those metrics from your policy of what you were going to measure and how, and you'll be able to see, okay, are we starting to meet the goals of designing this facility safely that we set out to do. Once we get the facility built, now it comes time to turn the key, start the thing up. So we're going to be commissioning and closing out the project. This is where the facility turned over and we start doing the actual testing for any performance related issues. Um, Sometimes in this phase, you will have an independent commissioning party or a commissioning agent, depending on the type of facility, depending on the client. And this is also where you're going to start going through and looking at hazard mitigations now that things are in operation. People are using the facility. They're coming into the office. They're going home. Are they getting around the facility okay? Do we have any trip hazards? What's going on? What's working? What's not working? Everybody is involved at this point, especially the owner, the operations staff, because they are on site and running the facility, and then the construction management team as part of the overall commissioning and closeout process with their contract. They will also be involved in a lot of this because as we start closing out the job, we all know that comes with the big pay at the end of the job. Everybody wants to get final paid on that. So there is a very vigorous effort to make sure that every item is taken care of on the punch list and everybody can go on to the next big adventure. Key output here is going to be your final commissioning report, which will come from either your agent or your independent commissioning party, basically assuring through documentation that the facility has been built and is performing to the required performance requirements, specifications, and then also any noted deviations from anything that may have significantly changed. So there's a lot of benefits from prevention through design. Sustainability. Safety and health relates to the social aspect of sustainability. If people work in safe places, they are safe, they feel safe. If the environments are healthy, they feel good. You don't have people getting sick at work because the air quality is not good. Protects the human resources in the facility life cycle, and just generally produces working conditions that promote overall safety and health. Operational savings. in safe environments, unsafe incidents are less likely. And I think if you talk with most facility managers, most operations managers, especially in manufacturing environments, workplace injuries can be very costly. Even the smallest, most minute thing that may happen, an injury it costs time, it costs money, it costs, maybe physical ailments, somebody gets injured. It's just it's just not a good thing. And operationally, because you're going to be down employees, productivity suffers. So operationally, having a safe environment, you are unlikely to have a significant amount of incidents. Reduction in rework during construction and turnover. Non-compliance with the HSE requirements, identify those early on, can save you time, can save you money. And we all know that I think as you start adding things into a project later on, you don't want to extend the schedule, but depending on what it is and the severity of maybe what needs to be redone, it could very well do that. So catching the potential risk early on through PTD will help reducing the rework and schedule creep. So I mentioned early on that there was a couple case studies and some examples that we would look at. So the first case study here I want to look at is it's in the design phase, and the situation to be analyzed was the protection of workers while on the facility of the roof. Now, this wasn't talking about folks on the roof during construction. This was pertaining to people working on the roof, maybe servicing air handlers equipment, things that required access to the roof to maintain the facility. So the identification of the potential hazards that were found were trips, slips, falls, which that is probably that and fall protection is probably one of the top two or three OSHA accident indicators pretty much every year. Typically, you will install fall protection systems, or in this case, option was brought up to increase the parapet height to provide the required protection. So instead of installing tie-off points, restraint devices, edge protection up on top of the roof, the designers looked at possibly increasing the parapet height to the required height where fall protection would not be required on the roof. So the analysis and options between the two, the fall protection systems, there was a significant cost to the client in ongoing equipment cost and upkeep. Not just stuff that you put up there and forget about it and just go use it whenever you're up there. There is significant cost involved with ongoing monitoring, inspections, and training to use. Anytime anybody new goes up on that roof, they need to be trained in, not only how to be safe from fall protection, but how to use the system. And the overall risk of PPE not being used properly at all is probably fairly high. I think we've all seen probably some instances where a little bit better application of fall protection being used would probably be a good idea. So it's a fairly severe risk level on the spectrum when they went through and did their performa. So by increase, they then went and looked at increasing the parapet wall height. So instead of having the lower parapet height, they looked at designing one in that would meet the OSHA guardrail requirement of 39 to 42 inches. So when somebody's up on that roof, it would eliminate the need for a fall restraint system because the guardrail would be high enough that somebody could not just fall over the edge of the roof. It allows for a larger area of the roof to be used for mounted equipment if they would like. Typically, you have got somewhere between a 6 and a 10 foot range that you don't want to get anything close to the edge. Just from a basic fall protection, edge protection standpoint, by having the parapet there at the edge, you have a lot more roof area to work with. People won't have to worry about getting too close to the edge because they're going to be protected because of the high parapet wall. Aesthetically pleasing, you don't see a lot of things behind it. And it protects the workers not only during the construction, but the post-construction operations, as I just mentioned. So by looking at the square footage cost of what it was going to be different between upkeep of a fall protection system and trainings and ongoing risk, the increased parapet wall height won out. Return on investment was good, and that was the solution, which was developed through working with client operations, HSE folks, architectural team, and design team. So it was a literal team effort. And on that one, case study 2 was from an operational standpoint. We were going through design on a facility, a lab facility, so there was a lot of air monitoring devices up in the ceiling, and this was going to require the facility manager to have people access these assets up above the ceiling, probably once every few months, to go through and make sure everything's calibrated. There was just a lot of preventive maintenance with these air monitoring devices for this lab environment. So identification of the major hazards and getting up there to do this, and the ceiling was just jammed with mechanicals. It was a real maze to try to figure out how to get everything to sit nicely. Head and eye injuries, poking yourself, knocking your head on something when you're getting above the ceiling, strains, sprains, stretching, you're climbing up and down ladders or you're moving around in a lift. And of course, you're working at heights, so there's always that issue of falling. Couple of the proposed solutions that were looked at was identifying the equipment required that required unimpeded access, and then coordinating the physical distance clearance required in the BIM model. So we were able to come up with this little handy dandy chart. And again, it's probably easier to see if on a PDF, but we identified several different types of access that were required based on the operational aspect of the assets. So if this is just something that needed to be looked at, not really touched, just needed to be quickly verified, we took the size of it, the height of it, and developed a working range. And I think those that work in BIM, our BIM operator at the time, he called it the no-fly zone. He would block that out in design as a no-fly zone around that asset, based on the height of the asset and what type of device was going to be used to get there, whether we were using a ladder, a single man lift, if it may need scaffold, it was a boom lift, whatever somebody may be able to get up and check what was up in the ceiling. We would, based on the size of the equipment needed, that would either increase or decrease the size of the no-fly zone. So we had a lot of these no-fly zones around the mechanical design of the lab, and essentially what it did was, they needed to get up and check the air monitoring or the gas monitoring boxes up in the ceiling. They pretty much had free and unimpeded access to get up there. Nobody was crawling around on stuff. A few difficulties here and there. It didn't solve everything, but it really did cut down on the amount of time that was required to access, the difficulties in having to use different operational equipment, and that ultimately saved time. And in the operations of a facility ongoing, if you are saving time, you're probably saving money. So that was another case study that was done from an operational aspect. So keys to successful PD implementation. because I know we're running up against time here. Number one, overall commitment to safety. It's a safety culture. It's the policy statement when you execute your prevention through design uh, framework, and then ongoing and training education of people. Stakeholder management, understand the roles and the responsibilities of everyone involved, their level of influence, and have them involved in all aspects of the HS&E as much as possible. I often tell people when you're building a facility, the person who's going to be managing that facility is probably going to be should be your best friend, because they know the ins and outs of what needs to happen. And then collaboration collaboration and communication. I think we're starting to see a lot different applications now with delivering projects, more design build, more integrated project delivery, and we all know the technology has just gone bonkers. So a lot of collaboration and a lot of communication are keys, not only to just any successful project, but especially in the framework of prevention through design. So just to recap real quick, because we're getting close to the end, prevention through design is a concept introduced and led by NIOSH. It seeks to design out or minimize hazards, and it touches every phase of the facility life cycle. Tools and resources used in practice are the PTD policy statement, the risk assessment pro forma, construction slide rule, and then various checklist and reporting tools. And the key to successfully executing prevention through design is a culture of safety, stakeholder management and stakeholder involvement, and continued collaboration and communication. So I will I will see if we've got any questions or anything here. Again, my name is Mark Ogg. I'm a senior project manager with JLL, and here's my information. You can reach me at mark.ogg@jll.com or markogg@icloud.com. And I think, let me get on I think I've got one. Yes. The back here, there are several good references. And again, if anybody's interested in a PDF of this, please let me know. A lot of good information back here, references that I used, studies that were part of this presentation on the prevention through design project delivery process. Oregon State University several years ago did a really, really good study on this. You can check out Oregon State. Google Oregon State PDD, and it should direct you to the study information and all of the outcomes from it. So again, thank you. Keep in mind, next month we will be discussing volumetric modular design. I believe Lane Booker told me that was what the topic was going to be. So that will be in May from CSINext. And again, thanks everybody. If I don't see any, I have one question here. Yes, Marvin, may I request a PDF? Yes, I will get you a PDF of this as soon as I get back to my desk. I have your email from the sign up, and I think that's it. So again, thank you folks. Enjoyed it. And keep an eye out on CSINext.org for upcoming programs. So thank you again.